In this section, I'm going to discuss the very exciting topic of confidence intervals. You'll see them as CI. Now, they are everywhere in the literature. You'll see them mentioned after means, after standard deviations, after variances, so many, 95% usually CI confidence interval. There are many uncertainties about what it means exactly. I think there's probably a poor understanding of the term confidence intervals. Now remember what our aim was. Our aim was to take a sample, calculate a statistic, and use that statistic as some barometer of the patient parameter. We're going to infer it to a population, but it is somehow has to represent the patient, the population parameter. So in essence, what we're trying to do here is, with confidence intervals, is to put bounds, upper and lower bounds, around the sample statistic that we found, and we would hope that the true population parameter falls within those bounds. So let's look at an example from the literature itself. Din and colleagues, they looked at maternal HIV seroconversion during pregnancy. Unfortunate situation. Now they had a sample of over 9,802 mother-child pairs, and they established a seroconversion rate during pregnancy of about 3.3%. That was their mean. And they put around that 95% confidence intervals of 2.8 to 3.8%. What does that really mean? What does it mean, that 2.8 to 3.8%, which you would notice is on either side of the 3.3% that they found in their study? Now remember, we don't know what it really is out there in the large population. We do not examine the whole population. We don't investigate the whole population. It's impossible. We only have the data at hand from that sample. Now it's a large sample, 9,802. But it really does refer only to the data that's at hand. That's the only mean that we can really calculate. Now, we must infer that 3.3% to the larger population, so that when a healthcare worker who's working on that same type of population can use those results. Say, for instance, they have to come up with some sort of interventional program. They've got to use those results. They've got to know what the likelihood is, what the likely values are that the patient, the population parameter might be. Now, how sure are we that the value that was found, that 3.3 was found, how sure are we that that really is the true patient, the population parameter out there? Well, if we chose the sample properly, if it was proper random selection, and that sample does reflect the population, then that 3.3% must really be somewhere in the ballpark. It must be close. And for that, we need this concept of confidence levels, and we'll discuss that next.